Well, good day, everybody. I've decided today to make a little video about object-oriented programming, in specific covering inheritance. When should one inherit? When should one not inherit? Multiple inheritance versus single inheritance, and then, of course, the principle of composition versus inheritance, and dependency injection, and the whole concept of is a, has a, and needs a, or requires a. All right, so we're going to start off with some C++ code here. So this is an example. So we're going to be looking at C++ and C#. So in C++ here, we have an example of where you can do multiple inheritance. And in C# you don't. You've got single inheritance, okay? You have multiple interface inheritance, but I'm referring to classes themselves now, all right? So in C++, everything I'm going to show you in C# just now, you can do in C++ as well. But C++ being the fact that it's multiple inheritance, you've got far more choices in how you do your inheritance model. And you can, of course, limit yourself to only single inheritance in C++ as well. But all right, so if we just look at this quick little example, yeah. So all it's really about is, if I just run it quickly here. Okay, and let's zoom in a little bit so we can all see what's going on. Zoom in and zoom in one more. Okay, so what's happening here is we've got a whole lot of animals, all right, like for instance a white shark, a tiny fish, weird grass, a buffalo, and a tiger. Now these energy levels is the energy of the actual animal. So the shark has got an energy of 25 at the moment. So all of them are the same. We just initialize it to 25. So they're all quite low on energy at the moment, all right? And then they go ahead and they eat, okay? And so what happens is the white shark eats the tiny fish eats some weird grass, the buffalo also eats some weird grass, and the tiger eats the buffalo. And those percentages that you see now are the result after they've eaten. All right, so if we come look at our code, so all you see here is in this little bit here, so like for instance the white shark, we initialize the white shark with an energy value. In other words, what value does something else get, some other carnivore get, if they eat this white shark? And for instance, like here, we've got this weird grass, which is carnivorous, and its energy value is only 2, all right? So not much energy in the grass. So something like a buffalo, which itself has got high energy value, but it eats grass. It needs to eat a lot of grass before it gets any energy out of the grass. So yeah, we just show our initial energy values, then we eat, and then here we say, okay, so the tiny fish eats some weird grass, the white shark eats the tiny fish, the buffalo eats a whole lot of weird grass, and then the tiger eats the buffalo. All right, so we'll just run that one more time again, just so you can see the outputs one last time. Let's just always do that. Zoom in and zoom in. All right, so so the white shark is at 37. Of course, he ate the little tiny fish. The tiny fish only gained 2 from 25 to 27 because he only ate one little bit of grass, and the grass, as it shows here, is worth only 2. All right. The buffalo ate a whole lot. All right, so it moved from 35 up to 80. And the tiger ate the buffalo, which is extreme amount of energy that he ate, and therefore his own energy is fully topped up. Okay, so if we look at the classes, so first we define a carnivore and a herbivore. So in other words, our white shark, for instance, is a carnivore, and our buffalo is a herbivore. All right, and the carnivore and the herbivore have got, they inherit from another class called gather food, which is a method or some methods functionality which allows them to eat. All right, and then they themselves inherit from, and then the carnivores also inherit from life form. So both the carnivore and the herbivore inherit from gather food and life form. All right, we're not discussing perfect design here. We're just covering the idea that multiple inheritance versus single, etc. All right, so if we just expand that, all it really does is on the initializer of carnivore, it also calls the initializer of the life form to pass the energy value through. The same for the herbivore. All right, so let's just collapse all this again. All right, so if we go and look at gather food, all right, so gather food has got a method on it called eat, and what it does is it eats some other life form, all right, and it goes and sees if I myself currently am hungry, then take in all the energy of the food that I've just eaten. But if I'm not particularly hungry, only take half the energy of the food I've just eaten. And then we just say don't allow our energy levels to go beyond 100%. And then over here, if the energy is below 75, my current energy, then that means I'm very hungry. So that will mean I'm going to take in all the food, all the energy value of the food I eat, else I'm only going to take in the half. So as you call this eat method over and over and over, the energy value will climb, and at some point am hungry is going to be set to no, I'm not that hungry anymore, it's above 75, it's only going to be half. All right, and then we have a life form, and it just says what is the life form's energy value, and why did I put is hungry here? You just see gather food, am hungry, and is hungry. Yeah, this doesn't need to be here. All right, if I'm not mistaken. Okay, and everything should be fine. All right, so let's just make sure, just run it again, see it all compiles. Yes, everything works fine. All right, so now I'll expand it all and we can look at everything again. All right, so we're just saying, all right, what was our initial energy values, and we do some eating, and then what are our new values, all right, based on eating each other. All right, so we've got our herbivore and our carnivore class, of which we can create a white shark, we can create a whale shark, we can create a tiny fish, a small fish, or whatever, a tiger, a lion, a buffalo, a cow, a sheep, weird grass, trees, whatever the case may be. They all fall into a class of a carnivore or herbivore, which is a life form, and they all have the ability to gather food. Right, there comes in the multiple inheritance, the gather food, and the life form. All right, so as I said, in C#, for instance, you don't have the option of doing multiple inheritance. But that's not necessarily a problem. In fact, it could be a good thing. But it really depends. Again, like I say, in C++, you got the option. So depending on your actual user case, you can decide if you are going to do multiple inheritance or not. But this particular example, we can get rid of multiple inheritance. We don't need to do multiple inheritance, okay, of gather food and life form. All right, we can switch gather food to inherit life form. So in other words, carnivore only inherits gather food, and gather food inherits life form, versus at the moment carnivore inherits both gather food and life form. All right, so I'm going to take all this code and just copy it into memory here, and I'm going to go to a C# project. All right, so here we have our little hello world in C#, and what I'm going to do is I'm going to paste int main didn't come over. Let's just go back here to C++ again. I think it's because it's not expanded here. Yeah, okay, Control A, Control C. All right, and we run over to C#. Okay, and we paste all of that. All right, so we've got our C# code up top here. All right, and we've got our C++ code at the bottom here. So all we're going to do is we're going to convert our C++ code to be C#. All right, and so let me quickly do that. Okay, so I did the quick conversion there, and just porting from C++ to C#. Now, okay, so this is what the printout will look like. Basically, the equivalent of what C# does. In fact, the exact same. Well, I mean, in functionality. And all right, but so what I did then is I copy pasted those classes over from C++ and made the changes that are needed in C#, all right, except for the fact that I did the multiple inheritance in C#, which will give us errors, of course. So if we go up here, it tells us that it's got errors, all right. So if we look at Carnivore, for instance, it used to, on the C++ side, it had public gather food and public life form. Now in C# you don't have to say public, all right. So what it's doing is it's saying, okay, so we can inherit from gather food, but we can't inherit from life form, all right. Only allowed to inherit from one. So what we can do is, we can inherit life form from gather food or gather food from life form, whichever one you want. But let's pull out life form, for instance. So we're going to have Carnivore. Instead of Carnivore inheriting from gather food and life form, which we can't do in C#, we're going to have Carnivore inherit from gather food and gather food inherit from life form, which will do the exact same thing for us at the end of the day. So if we just cut that out, and we'll also come down here to our herbivore, all right, and okay, we're going to have problems with this constructor as well. So, all right, so if we come to gather food here, I already made it inherit from life form, which wasn't previously. Right, so that inherits, and then, okay, we just need to add our constructor, okay, for gather food, which will then call the base of life form. All right, so it's a public constructor, gather food. It's basically the same as what we've got here. Well, not basically, it's the same. All right, and then that will call the base classes, in other words, life forms constructor, and pass it the initial energy value. All right, and then the same we'll need to do here then. And we'll have to call the base, which is now gather food and herbivore, and here we're going to have to call the base, all right, which is initial food. Sorry, all right, okay, what did I do wrong? Oh, okay, sorry, we just got to give it an implementation there, and all right, we should have no problems at all. Okay, and that's it now. So if we just run it again, we should have the same output basically as we had. All right, so there's 25%, shark 37, 20. Okay, so we got the exact same output, all right, that we had in C++, with multiple inheritance. We now have in C# with single inheritance. Okay, now in this particular case, all right, oops, what was that? All right, in this particular example that I used, okay, you can convert your solution, your use case, from multiple to single inheritance. Okay, now because C# has the option of multiple inheritance, C++ has the option of multiple inheritance, you can tackle different use cases and different models and so forth. But in this example, I'm just showing you that how you can convert from multiple to single, but it's all about the way that you think about your problem and what your solution is. C++ allows you to approach it in a slightly different way. C# is a little bit more rigid, but that's not necessarily a bad thing. All right, so what we've looked at there then is switching over from multiple to single inheritance. All right, so another example where you want to switch or where you want to use multiple inheritance is, for instance, let's say, for instance, you are building a car, all right? And then you'd say, well, a car consists of separate stuff, like, for instance, an engine, windows, doors, wheels, etc. Okay, so let's just take, for instance, the idea of a car having an engine. Now, one approach that I find a lot of people do, okay, maybe this is self-evident to most of you, but possibly not. Okay, so we can, for instance, let's go and create a class called engine. All right, and that class has got various properties on it. For instance, you know, the engine size. Okay, so all right, so what else do we have on a car? Sorry, on an engine, cubic engine, centimeter. Oh, and maybe is it diesel or petrol, gas? Okay, so let's just say, or electric. That could be an enumeration that you should actually use there. But let's just say, is electric true or false? All right, so is electric sorry, it's very early, 4:50 in the morning, and I've been working since 12, as I do just about every day. Okay, so all right, so that's a Boolean. All right, is electric. And what else do we have for an engine? Well, then we shouldn't call it engine. It should be the driver. But well, let's okay. Is it, well, let's just say is gas. Okay, or is diesel. All right, so that's more appropriate to an engine. Okay, cubic inches and is diesel. All right, and we can add has a turbo, for instance, or again, you should use the enum because it might have, instead of a turbo, but a compressor. Okay, is diesel is turbo, or let's say has turbo. All right, and there we have, let's say, for instance, a definition of an engine. Okay, then we can go and we say class, and we say let's call it, just should be vehicle, for instance, but let's say class car. All right, and class car, for instance, has the ability to drive. So let's say let's just say public function, oops, function, soft course, yeah, you don't do that, public void, let's say drive. Okay, and it takes, for instance, parameters, I don't know, direction, etc. Let's just say, for instance, in a Cartesian plane, so we'll just change it to move, and we'll give them our the next XY coordinates. Come on. So let's just say int x, oops, int y. All right, and then we int 7, int y. Well, we can make that part of the constructor rather. No, we're moving, so we can't do that. All right, so okay, so it does something. All right, it moves. But now remember, a car has an engine. So if we're building this car now, let's say we're writing this code for a factory or something, and let's say we're writing it for McLaren, right? And all right, so a car has an engine. Now, what a lot of guys go and do is they will now inherit from engine. All right, and that's correct now. So the car has an engine. All right, so let's create a new instance of our car. Okay, so it is car, my car equals new car. All right, and then we say my car, for instance, we want to tell them what's the cubic inches, or let's say it has a turbo. Okay, it is true, and so we have, okay, a car which has inherited an engine. So a car has an engine. Okay, now obviously if you want to start inheriting more things, okay, like for instance car has, for instance, there's the keyword has. The car isn't an engine. All right, the car has an engine. So here we're getting into that principle of is a and has a. All right, composition and so forth. So instead of inheriting car, okay, you should rather have a property. So let's say public, sorry, instead of inheriting engine, all right, so we rather create a public property, all right, called well, it should be engine. Okay, and we do a get set on that. All right, and then maybe in the constructor we can accept some values. So public car all right, so this engine, for instance, you could now at this point, for instance, create a new instance of it. So we can say engine equals a new engine engine. Okay, and then we can say yeah, engine, and now we can give it some cubic inches, for instance, or it has a turbo equals true. Okay, so let's take that out. All right, so what we've done now is, instead of inheriting an engine, okay, so it's not is an engine but has an engine. Okay, so we've got rid of inheritance, okay, for designing our car. Oh, all right, so, or building our car. Now there's another issue that we have here, for instance, and that is another principle, well, encapsulation from object-oriented programming, and that this engine is actually data, and it should be hidden data. All right, so you shouldn't be able to come down, all right, to like here, for instance, and then say my car dot engine dot has turbo equals true. All right, it's based on something which, if I remember correctly from a few years ago, it's the law of Demeter, that says that you should not give access directly to your inner data to the external world. So we can, for instance, use a proxy pattern here. Okay, so in other words, we know that the engine has, for instance, got the property called has turbo. All right, so the engine, we're going to make it private. All right, so we can no longer refer to the engine anymore. We can't give it a turbo. All right, but what you can do is, obviously in the constructor, all right, you can say send through a true, and that is bool has turbo. Okay, oops, yeah, has turbo. So where did I do this now? No, man, it's because that should be here. All right, so has turbo, and then over here we can say it equals has turbo. All right, so what we've done now is we've injected information, okay, into our car, okay, that is to be used by the engine of the car, okay, via the constructor. All right, now we're going to get deeper into this later, dependency injection, but this is just sending through data, for instance, for the engine. Now this is one way of doing it, but now remember, a car consists of many components, okay, so you can't have a constructor that has all the properties of an engine, for instance. So a constructor that has turbo, comma, is diesel, comma, cubic inches, and then you have wheels like the rubber that it's made of, comma, 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 in your constructor. You can't do that, all right? Something else, or something that you can do, all right, is, for instance, to, instead of sending everything through each property in the constructor, let's, for instance, expose new methods, all right, on our car object, which proxies the method or the properties of the engine. So it maps directly through, all right? So in other words, the car now will have, let's say, for instance, a property called has turbo, all right? So if we come up here, okay, so the car has now a property called has turbo, but what it should do is, when you set it or get it, all right, it should talk to the engine, all right? So if we say get, all right, and then we say return engine dot has turbo, and then when we say set, and then we say engine dot has turbo equals value. All right, so now we've got a private engine on the car, all right, but we've exposed the property of the car called has turbo, which maps through to the engine's has turbo. So if we come down to our car, we see has turbo. We can set it. Okay. Oh, sorry. Sorry, we're in the wrong place here. Sorry. Yeah. So if I come to my car, and now I say dot has turbo, there it is. All right. So we can say true. All right. So that's one way of approaching the problem. But now, okay, for every single property on engine, okay, you have to expose or create a property on your car object that maps to the property on that engine. All right, because the engine is internal. Okay, now that is actually the right way to do it, because of the fact that if, for instance, the engine's properties, let's say it gets additional properties, all right, and you haven't exposed those properties on the car, but you compile your software, your program won't break. All right, you'll have to release a new version of this car that does expose those properties. Okay, so yes, you can get clever, for instance, and instead of having properties that map to every single possible property being added to your car class, like we did now with this has turbo, having many of them, you can, for instance, have internal, your own engine. Let's call it, for instance, our engine. Sorry, our engine. Okay, and our engine maps to, for instance, this is just one way you can do it. Engine. Okay, and then engine equals value. All right, so what we're doing now is return engine. Sorry, yeah, we got to return engine. Yeah. Okay, so what we've done now is we created a property directly for engine. All right, but our own engine. So we've got the internal engine, all right, and our own engine, but that's just a direct mapping across. Okay. As the properties on engine changes, so the properties on our engine will change, and that's not necessarily what we want. Okay, so that's not necessarily the best solution. So still, like I say, rather put properties out there that maps to everything on our internal engine. Okay, let's just do that back again. Okay, so let's close that down. Has a turbo. All right, so okay, so that's the basics of is a and has a. All right, so a car is not an engine, so we don't inherit engine, but it does have an engine. Okay, so we compose it of, it's composed of an engine, but it's also composed of other things. So let's say, for instance, it's composed of wheels. All right, wheels. We make that private, wheels, and then we say wheels. All right, so, and then we create a class up top here called, oops, okay, you do know obviously that your classes and so forth should actually be in different CS files and so forth. I'm just doing it here so that we've got everything on the same page. All right, so it's easier to see. All right, so wheels, for instance, has got, let's say, for instance, profile. Is it low profile or high profile? So let's just say public bool is low profile. All right, and do a get and set on that. All right. So we've got wheels, and we can set whether it's low profile, etc. Okay, whatever you want to set for a wheel. So we've got two parts of a vehicle now, of a car. We've got wheels and engine. And if we just collapse all this, Okay. All right, so our car consists of both an engine and the wheels. All right. Some cars might have two engines, you know, so you can just stick that in an array of some kind, you know, generic list of engines. Or you can have, like, for instance, instead of wheels, you can have wheel. All right, and then have a generic list of wheels and keep adding the number of wheels that you require. Because, like, let's say maybe it's a car with only 3 wheels, you know, 1 in front and 2 at the back. Alternatively, maybe you change car to vehicle, and then it becomes, for instance, like a motorcycle has 2 wheels. But that's how you play with your model and see what you need. Okay, but what we've done now is, all right, so we've got an engine and wheels, and then let's say we want to, for instance, now go and set our number of wheels. All right, public sorry, not number of wheels, is profile. Yeah, high or low profile. So we can just copy that as is. All right, and okay, and then this should map to our actual wheel component. So we say get, and then we say, you could say this dot wheels. Okay, I suppose that is the newer way of doing things. So has turbo, so we say this dot and this. Sorry, man. This dot. I always get confused between this and self. Okay. All right. So that goes there. All right, and then this dot wheels. All right. So we want to return the wheels. All right, and then on our setter, we want to say this dot wheels equals value. All right. Sorry, and that's not a boolean, it's wheels. Sorry. No, sorry, it is bool. All right, and then that means it's this dot wheels dot is low profile, and this dot wheel set this dot wheels dot is low profile. Okay, so now we've got, if we come down here to our public, what's going on? Why is he complaining here? Duplicate public modifier. What did I do? Oh, sorry, I typed in the word public here. Okay. All right, so if we come down to our car now, and we say my car dot is low profile equals true. So we've specified that, let's say for instance that this car is my McLaren. Okay, McLaren. All right. And okay, and so you can set it up. Now the nice thing is, what happens, like I said just now, is if somebody goes, for instance, and adds some new property to our wheels. Okay, so we have for instance, a wheels count. You know, how many wheels are there? Okay, so that will be, let's say, I'm so used to, you know, in C# you normally just say int, but I'm used to being a little bit more verbose than that and specifying, you know, it's a byte, or if it's an unsigned byte, or, you know, is it a long, is it a 16-bit, 32-bit, whatever the case may be. But okay, so for simplicity, we're not going to do that now. So, and then what did I say? Wheels count. All right, wheels count. Okay, now if we come down to our car, okay, McLaren, all right, we don't have access to that wheels count. All right, so now you can say, yeah, but the solution is if we expose the engine again, all right, okay, then we can directly set it. But remember, the engine is data, all right, that's living inside the car. We should not have direct access to it, so we're going to have to add a new property, okay, to map directly to it. Now in this particular example, okay, it might not seem like such a big deal. You know, if they go and add something, you know, it doesn't reflect on our car. we actually have to add a property for it. You say, well, that's extra work. It doesn't just automatically generate all the way through, trickle through, from the back end through to the front end, and boom, suddenly you have a new property available. That can actually cause problems on a lot of projects, these things that happen automatically, automagically. Because the thing is, you have to be a little bit more specific, a little bit more verbose in your intentions of what this car can do. All right. So the mere fact, for instance, that the engine, that the wheels has got a wheels count, doesn't mean you want people to be able to, or the user of your class, you don't want them to have access to the wheels count. Okay, because for instance, in your case, you can say, well, this is a normal car, all right, and a car, for instance, always has has four wheels. In our factory now, we're creating supercars. There's no three-wheeled cars, right? So instead of saying, okay, well, let's set it to 4, all right, so what we can do is on our constructor, we come here and we say wheels wheels count equals 4. All right, and we've now set our wheels count. Okay, so even though our wheels count is not exposed to the external world, okay, you might want to do that, and you'll have to do that through a property again. But maybe you only want it because you want to do calculations of how fast this vehicle is around a corner. Okay, so what you can do is you can use your profiles and your number of wheels, and maybe you want to do tests and give it 6 wheels just to see how quick it is around a corner. So when you do your move, for instance, your calculations inside your move, you can take your wheels count into account of how the movement around a corner is affected and so forth. But you don't want your count to be set by the user of your object. So what you're doing is you're hiding data, you're encapsulating data. Okay, so like I say, is a versus has a. The car is not an engine, and the car is not a wheels. The car has an engine and has wheels. All right. Then we move on to our last step here, which is it uses a, or needs a, or requires a. Okay, so let's say, for instance, as an example, we want to add logging to our application. All right, so what you can go and do is, for instance, let's go and create a logging class. Again, like I say, this should be in a different namespace, a different CS file, etc. But to keep things simple, we're doing it all here. All right, so let's say class, let's call it logger. All right, and it has a function on it, which you can have, well, let's just call it public, I don't know, log, okay, and it takes a string, which is some information to log. All right, and then public void, that's not a constructor, it's just a method. All right, so sorry, log. Okay, so what are we going to do? We're just going to write to the console. Okay, console.writeLine, console.writeLine. You can put the date time in there and all sorts of things, but let's just say we're going to keep it simple. We're just going to say, and we write whatever you've got in the log or to the screen. All right, and you can obviously have different functions on your logger, like you might want to have as only log to file. Okay. Okay, so yeah, so what we're going to do is everything that logs to screen also has to log to file. All right, so we can say log to file, and we send through the to log for it. All right, so everything that we log to the screen is also going to log to file, and some things we've got the option of only logging it to file. So in other words, the screen stuff is what we want to show user, and a lot of the trace information, for instance, we want to write only to the file. We don't want to show the user thousands of lines of code when we're debugging. Okay, So when we come to our car now, all right, so let's say for instance on our move, okay, inside here we want to, let's say some event, like maybe for instance on our move we found that we're off the track and we want to log that. All right, so for let's say you know, you work out the coordinates, like I say, it's in a Cartesian. If your x and your y is so and so, then log. But let's just say, so what we want to do is we want to talk to the logger. All right, so you could create, because the logger is in the same namespace, it's accessible to this move function. All right, you can just create a new instance of the logger. All right, so logger log equals new logger. All right, and then we want to say log.log. No, we want to log to screen and file. But I didn't actually. Yeah, it's, this should actually not. That should be writing to file. All right, so writing to screen only. Sorry, so yeah, we want to write to the screen and the file, and we want to write a piece of text. We are off the road. All right, and that'll work. All right, but that doesn't mean it's a good thing to do. So if we say McLaren.move, okay, and we give him his new x and y coordinates. All right, and let's say for instance we execute that now. Oops, I got a problem here. Expected a semicolon, I missed out here. So where is that now? Come on, what did I do wrong here now? Yeah, oh, this dot, sorry, is that not it? This dot engine. No, still complaining about that. Why? Or is it just that Visual Studio Code is not? Oh, it says there's two errors. Where's the other error? Okay, so that one's 3128, 3128. I've fixed it. I mean, let's have a look. Okay, so it was Visual Studio Code. Now, unhandled exception at Boolean has turbo 50 and 63. Let's see, 50 and 63. No, man, that's not true. Objects reference. Oh, of course. Okay. Okay. So, all right. Our engine. Okay. Our wheels count. Okay. We've never actually created an instance of our wheels. All right. So let's just create our wheels. Okay. Wheels equals new wheels. New wheels. I think that's our problem here. All right. Okay, we are off the road. It's logged that for us. Okay, so our car, which has an engine and has wheels, okay, has moved, and based on some calculation, we've noticed we're off the road. Now the issue here is the fact that we are directly accessing our logger, okay. But remember, in object-oriented programming, you shouldn't be jumping. Everything should be, well, in any form of modular programming, okay, you should be passing things through via parameters and so forth. So what we can do, again, for instance, let's take what we did just now. So let's pass through a logger, all right, to our car, all right. Oops. So on our constructor, we are passing through a logger, all right, and then we create a property. For instance, you could make it private, all right. Well, okay, again, yeah, All right, now this goes against what I was saying just now, for instance, but how I would use a logger in specific as an example. It's something that's probably not going to change, okay? An engine might change, new properties are added, etc. But a logger, you might want to give the world outside direct access, so you can create a property which is public, all right, of type logger. All right, so we're getting a logger in, okay? So that means it's instantiated already. We don't have to instantiate our logger. We're getting one in, all right? So that's going to be instantiated outside our class and then be sent to us. So if you take the logger, and like I said, we can create a property for it, okay? We'll make it a public of type logger, all right? But okay. You already know I want to say something. Okay, logger, and then we do a get set on that. Sorry, we do a get on it, all right, and a private set, all right, so that the outside world cannot set our logger. They have to go through our constructor. Okay, so we can do that, all right. So if we come here, for instance, so it is our this dot, okay, this dot log, log, okay, this dot log, and we log it. All right, so we can now, for instance, why is he? Oh, sorry, we got to send our, we got to create an instance of our logger. All right, so we got to send it through. So this is dependency injection. Okay, so our class, our car class requires or depends on an instance of the logger. It doesn't. It's not a logger itself. It doesn't inherit the logger, and it doesn't just go and create its own internal one of it. All right, it actually gets sent to it through the constructor. You can do dependency injection also through properties, but the most common form today is always to do it through your constructor. So basically, dependency injection is just passing objects into your constructor, okay, which you're using internally then. Okay, so if we say logger, create a new instance of our logger. So let's create new log equals new logger. All right, and then we send that new log in. Okay, so actually this logger here, that should be private. Okay, so it doesn't matter if that's set like that. All right, so we don't have access, okay, from the outside world, okay, to our logger. So if I say, for instance, car dot, okay, no man, McLaren dot, all right, there's nothing to do with logging here, okay, in our options. All right, but if we run the app, oops, all right, it'll still log for us. I still got an unhandled exception again. What did I do here? Object reference not set to an instance of an object. Oh, sorry. So I received it, but now I must set my internal logger. Sorry, this dot. Come on. This dot log equals log. All right, and then okay, so this dot wheels should also be. Well, this should be this dot wheels. I'm going to mention something about this now. Okay, this dot engine. All right, and that should be that. Okay, and we are off the road, it tells us. All right, so in other words, using dependency injection, okay, we've sent our logger through so that our car can do logging. All right, and okay, so that's basically the is a, has a, and uses a when it comes to object-oriented programming. And it's relevant to basically all object-oriented languages, C++, C#, etc. You know, freaking TypeScript. You think of it, it's relevant. Okay, just for interest's sake, one thing that I want to mention here is this using this. All right, why I personally don't like this. Okay, on a property perhaps, but let's say for instance you have internal variables. All right, but they are private. All right, so what a lot of people will do, they'll say private int. We call it a counter, for instance. Okay, how many times has this car method or been instantiated? Well, then it should be a static, but okay, it's some counter of some kind. All right, and we started off as 0, or let's say it's a const. Okay, okay, it doesn't really matter. Okay, so we've got some kind of class, a variable, and it's called counter. Now, the way that guys will access it then, for instance, let's say in our constructor, let's say we want to set the counter. Okay, they will say, based on the new way of doing things, okay, so here again, we're going to say this dot, okay. Now you should say as well, this dot counter, okay, equals, let's say 45, all right. Okay, or you know, it could have been sent in as a constructor parameter, or whatever the case may be. Yes, that's true. Okay, that's how a lot of people do it now. But the thing is, you can also forget to type in the word counter, and it'll still build. So how do you know you're referring to? If you wanted to make the point that you're referring to your own instance, okay, by specifying this, all right, and then you forget to do it. So your intention of informing the reader of your code that it's using your current instance's local counter, all right, forgetting to do it is now confusing to them, because you're using this all over the place, and then suddenly you aren't. And they say, well, what was your intentions here? Why are you doing that? You're obviously doing it for a reason. So it's an extra level of, you know, thought that they have to put into this. And they finally figured out, no, you actually just meant to say this dot, all right, and the boss comes and taps you over the knuckles and says, you know, why didn't you do that? Well, you can solve that problem entirely by going back to how we used to do things, all right? And I still do things that way. I use my underscore, all right? So I stick in my underscore. This is for field variables, okay? Now, if I use an underscore, there's no way that, you know, the convention is underscore is what we're going to be using. And if you forget to put in your underscore, you know, for a local instance of a variable, if you forget to put it in, okay, and then the thing won't build, okay? So, you know, using this, I don't really see the point in that. I'll just, for field variables, I'll use an underscore. In other words, something that or privates that you're not going to expose to the outer world. If you are going to expose it to the outer world, then you stick to your proper Pascal case naming, like we've got, for instance, up here. So I know that this is referring to something locally, and I don't have to specify this, all right? And counter is a hidden, so I know that if it's a capital, for instance, it's exposed to the outer world. Not necessarily, I mean, it could be private, like in the case of our log, but it's just doing the underscore, in my opinion, is one level less thought for somebody reading your code. It's much easier to understand. Okay, so I think we must bring this to an end. Okay, so we've looked at C++, that as an example, a prime example that can do multiple inheritance, and therefore you are free to do just about anything you want, and you can solve many solutions because of this freedom. But it does allow one, if you're not, for instance, a seasoned developer, to develop some bad practices. And then you've got some languages, like in this case we're looking at C#, that enforces that only one object may be inherited from, and that makes you look at your problem in the solution in a different way and design it differently. And so that is then we went further, and so we've got our is-a, and then we went further and we looked at has-a, so in other words, sending things through, and with our properties and so forth. You know, we have an engine, we have wheels, and then we looked finally at dependency injection and things being sent through on our constructor. And all right, guys, I hope you enjoyed it, And yeah, so composition, please, composition over inheritance. Okay, don't inherit. Thanks a lot, and I'll see you next time.